Welcome to this case study on distributed computing in big data analytics. Today, we live in a data driven world with organizations collecting petabytes of data daily. Analyzing this massive amount of data requires powerful computing resources that go beyond what a single machine can handle. Distributed computing is the key to unlocking the power of big data. Let's take a deep dive into how distributed systems enable the processing and analysis of big data. What is distributed computing? Distributed computing involves the use of multiple interconnected computers or nodes working together to solve a problem. These nodes share the computational load and communicate with each other, providing highly scalability and fault tolerance. In the context of big data analytics, distributed computing enables the processing of the large dataset that would be impossible to handle on a single machine. Importance of distributed computing in big data. Why is distributed computing so critical for big data analytics? Consider industries like healthcare, finance, and social media where the data grows exponentially. For example, analyzing the genomic data of patients, real-time stock market trends, or social media interaction generates massive data sets. A single computer simply doesn't have the capacity to process this data. Distributed systems split the data into the manageable chunks, process them in parallel, and then combine the results, drastically reducing the computation time. Real-world case study like Hadoop and Apache Spark. One of the most popular distributed computing frameworks for the big data analytics is Hadoop. Hadoop uses a map-reduce paradigm to process the large dataset across a distributed network of computers. It breaks down the task into the smaller pieces and processes them in a parallel across the multiple nodes. Another key player is Apache Spark, which performs the similar task but much faster. Spark uses in-memory processing and supports the real-time analytic, making it ideal for the application like real-time data streaming and machine learning. Both Hadoop and Spark have revolutionized the way big data is processed by leveraging the distributed computing. How distributed computing works in big data analytics. In a big data analytics, distributed computing typically follows these steps. Data splitting. Large datasets are divided into the smaller chunks, each of which is assigned to a different node for processing. Then the data processing. Each node processes its chunk of the data in parallel in Hadoop. This is done using the map-reduce model, where the map function breaks down the data and reduce function combines a result. Data aggregation. After all the chunks are processed, the results are aggregated and returned to the central system. This distributed approach significantly speeds up the processing and enables the analysis of large data in real time. Then the challenges in distributed computing for big data. While the distributed computing is powerful, it also comes with challenges. Some of the major issues are network failures, data consistency, load balancing, and overcoming these challenges requires advanced algorithms like error detection mechanisms and fault-tolerant systems. Then the future trends in distributed computing for big data. As technology evolves, we can expect even more exciting advancement in distributed computing for the big data. Quantum computing promises to revolutionize data processing by solving the problem exponentially faster than classical systems. Edge computing, which processes the data closer to where it is generated, will reduce the latency and bandwidth issues. And with the rise of the AI and machine learning, distributed system will not only process the data but also provide the smarter insights and prediction. The future of big data analytics is full of potential. So, to wrap up, the distributed computing is an essential tool for handling the massive scale of data we generate every day. From frameworks like Hadoop and Spark to the ongoing evolution of edge and quantum computing, distributed systems are enabling faster, more efficient big data analytics. Thanks for watching. If you found this case study helpful, don't forget to like, comment, and subscribe for more tutorials on parallel and distributed computing. Feel free to check out the links below for the additional resources on the big data analytics and distributed computing technologies. See you next time.